Hallo, it's Dumplet here. Here's an item on number theory. X and Y are both positive integers such that these two equations are true. And define M and N to be the number of primes, not necessarily distinct, in the prime factorization of X and Y, respectively. So just to give you guys an illustration of what this part means, let's just say we have X, we got X to be 3 raised to 4 times 5 cubed. Now, in the prime factorization, if I were to really factor it into individual factors that are prime, it's going to be 4 3s and 3 5s. Essentially, that's what the exponent means. So it's going to have a total of 7 prime numbers in the prime factorization, because we're not going to consider the 4 3s to be just like one value, which is just 1 3. So we're going to treat it as a 4. So in this case, m would have to be 7. So essentially, this part really just tells us that the 4 and the 3, to get the m, just simply add the exponents in the resulting number. And then I'm going to do the same for y to get for n. So that's going to be m and n. And we're asked to get what is 3m plus 2n. Credits to the American Invitational Math Examination for this item. As usual, pause this video if you'd like to give this item a try. But if you're done, let us dive into the solution. Now, as you can see in the yellow text, there is a property on the GCD and the LCM. I'm not sure if there's a name for it, but it is pretty well known. And we're going to use the fact that the GCD of x and y, I'm going to write it here, the GCD of x and y times the LCM of x and y. So the GCD times the LCM of two numbers, it's just going to output the two numbers here. Okay, this is going to be true for all positive integers x and y. So with this thing over here, it would be nice if I could take the product of the GCD and the LCM of x and y. Now, because we do have logarithms, and we know that addition in logarithms is going to give us the product of the things inside, for example, the x and the y, as well as the GCD and the LCM, I'm going to add the two equations. So the first part, log x plus log y, both with base 10. That part is essentially just going to be logarithm of xy with base 10. Now, the next part, it's going to be twice the logarithm of the GCD of x and y plus the logarithm of the LCM of x and y, both with base 10. So essentially, it's just going to be 2 times the logarithm in base 10 of the following, the GCD of x and y times the LCM of x and y, right? And that's the left-hand side, and the right-hand side is just simply 360, just 60 plus 570. Now, I'm going to use our nice property, the GCD times the LCM is equal to the product of the two numbers here. This part becomes xy, right? This part becomes xy, so it's going to become logarithm of xy with base 10 plus 2 times the logarithm of xy with base 10. That's going to be equal to 630. And then this part essentially is just 3 times the logarithm of xy with base 10. That's going to be equal to 630. I could solve for the logarithm of xy with base 10. That's going to be equal to 210. Now, converting this to exponential form, xy would be 10 raised to 210. And that's a very good information, because at least we're able to get some information, obviously. But aside from that, since the question kind of asks something about the prime factorization of x and y, the fact that xy is 10 raised to 210, that does give us a lot of information, because 10 raised to 210 can be written as 2 raised to 210 times 5 raised to 210. And that's going to give us a lot of information, because obviously x and y should also be in that format. So let's just say x is of the format 2 raised to a times 5 raised to b. We know it cannot have any other prime factors, and here I'm going to set a and b to be non-negative integers, right? So a or b can be 0, but they cannot be negative. So that's going to be that, and I could define all the other things. Let's just say y. Now I know xy, it's going to give this value, so y would have to be 2 raised to 210 minus a times 5 raised to 210 minus b. That must be the case, because xy is going to be this number over here. So with this, I could also write an expression for the GCD and the LCM. Now, the GCD, let's try to see. If we take the two numbers, the GCD of the two numbers, well, I know that the GCD, because I only have two numbers here, two prime numbers, 2 and 5, I know that the GCD of x and y, it's gonna be of the form 2 raised to something times 5 raised to something. To be specific, it's gonna be 2 raised to the minimum of a and 210 minus a, right? Whichever is smaller, essentially, times 5 raised to exactly the same thing, the minimum of b and 210 minus b. Right, exactly the same idea. That's going to be for the GCD. And for the LCM, well, since I'm taking the lowest common multiple, I'm going to take the maximum because, well, if I take the maximum, that's going to give me the common factor, essentially. So for the GCD, I take the minimum of the exponents in this case. So essentially, that's how we get the GCD and the LCM. Let me just finish writing here. Essentially, this is going to be the representation for the XY, the GCD, and the LCM. And we're going to use this to help us because, let me just put everything in. So I do have this thing now. And I do have two equations, but let me just focus on the top one for now, because essentially I do have logarithms in base 10, so I could combine them. So I'm just going to focus on the first one for now. So the first term is just, I'm just going to copy for now. The second term, I know of the property that this number in the front, I could bring it back to the exponent here. All right, I'm taking this thing on the inside squared. And, well, again, this is just a property. I could bring the exponent to the front and vice versa. So I know that I'm taking the square of 2 raised to this thing, the minimum, times 5 raised to this thing, the other minimum. So properties of exponents, I could just multiply the two exponents together. So the second term here, it's going to become plus the logarithm, well, still in base 10. And I'm working with 2 raised to twice the minimum. Again, this and that, the exponents multiply. That's the laws of exponents. So I'm just going to copy this one, right? That's going to be for the exponent of 2, and same thing for the exponent of 5 over here. Okay, and same thing, that's going to be equal to 60 on the right side. Now, I'll combine these two logarithms. They both have base 10. So I'll have the logarithm in base 10. That's going to be equal to, based from what I have here, I could multiply these two numbers, the 2 raised to a times 5 raised to b, and then this number here. And because both of them has 2's and 5's in the prime factorization, I could add the exponents. Again, laws of exponents. So it's going to be 2 raised to a plus the minimum, twice the minimum of a and 210 minus a, times 5 raised to b plus twice the minimum of b and 210 minus b, right? That's essentially the result. If I combine the two logarithms, that's going to be equal to 60. So I would know this thing on the inside, 2 raised to a plus twice the minimum of a and 210 minus a. Let me just copy this one. And this thing over here, it should equal to 10 raised to 60. I'm gonna convert this to exponential form. 10 raised to 60, but essentially I could write this as 2 raised to 60 times 5 raised to 60. And this will be a very interesting equation. Take a look. I have two equations here. How did I get those? I'm equating the exponents. So the first one, I equate the exponent into 2, right? That's the first equation you see. And then the second equation, I did the same thing. I equated the exponents. Now, all I have to do is to solve for a. Now, for a and b. Now, I know that a and b are positive integers, and I have to find a way to determine which of these two is smaller, right, in both cases. So I could just simply do some arguments here, just to have some reasoning. Now, because obviously the minimum of these two, well, since a is a positive integer, both of them must be positive. Well, we know a is some number from, a is non-negative, so a must be a certain number from 0 to 210. That's the same thing for a and b. They are integers from 0 to 210, they're non-negative. So, well, obviously they can't be greater than 210 because the exponents do not allow. So, A and B lies in that range. I'm going to focus on the first equation first. So, we know that these two numbers are both non-negative. So, the A plus twice the minimum here, it's going to be equal to 60. That's enough for us to say, well, I guess A can't be greater than 60 then. So, A would be less than or equal to 60. Now, if A is less than or equal to 60, then we could easily see that the minimum of A and 210 minus A, even if I take the extreme case here, it's always going to be the case that this thing, let's just say the maximum possible is 60. Now, even though if this is 60, this part is going to be 150. This 210 minus A would always be greater than the A. So the minimum of these two is actually just going to be the A. And that's going to allow me because this equation essentially just becomes A plus twice of the minimum, which is now A. That's going to be equal to 60. So 3A equals 60. That's going to give me A to be 20. In fact, same reasoning here for B. For the second equation here. Same reasoning, B would have to be the minimum, right? B would have to be the minimum, and then B plus 2B is going to be equal to 60. 3B equals 60, and then essentially B equals 20. So I'll have the values for A and B. Now recall that A and B are the exponents of the 2 and the 5 for my representation for X. So let me go back to the 4 values. X would have to be 2 raised to 20. Now that I have A and B to be 20. 2 raised to 20 times 5 raised to 20. And then Y would be 2 raised to 190 times 5 raised to 190. And then the GCD and the LCM, it would be pretty obvious to see. The GCD would be 2 raised to 20 times 5 raised to 20. And the LCM would be 2 raised to 190 times 5 raised to 190. Now these 4 are very important because we didn't really use the other equations. But I'm just going to show you that this is going to be correct. So you guys can check here. Whoops. You guys can check here that if I substitute the numbers in, again, I just kind of converted. Into the powers of 10. So X is essentially 10 raised to 120. Same for the Y, the GCD, and the LCM. Let me put everything in just to check. The logarithm of X with base 10 becomes 20. The second one, the GCD of X and Y, that's 10 raised to 20. So this part becomes a 20 times the 2 in the front. That's going to be 40. So this thing would be correct. And you guys would be able to check that in the second equation, essentially I'm just having 190 plus 380. That's going to be equal to 570. So the values are correct. Let's now get the values of M and N, which is going to be easy to get now because of what we realized a while ago in the prime factorization of X and Y. So these are the this is the prime factorization for X and Y. The M, I know that's going to be 22s and 25, so M would have to be 40. And for N, there's going to be 192s and 195s, so that's going to be a 380. 3M plus 2N would be 3 times 40, that's 120, plus 2 times 380, that's going to be 760. Add them up, we're going to get the final answer of 880. And there we go. Right? Hopefully you guys learned something new from this video, and I'll see you in the next one. Bye bye.